Hi everyone, my name is Andrew Grattan and I'll be presenting the subject selection for TAS courses. So we're going to focus this evening or this little presentation on the three: Design and Technology, Industrial and Engineering Studies. Apologies if there were some problems logging into the Zoom, some technical issues there, so we've produced this video in light of that. So first things are, where are the courses that existed in stage 5 and is there a prerequisite for studying in stage 6? So if you completed any of the TAS courses in stage 5, you would have studied design and technology, graphics technology, industrial technology, or perhaps information and software technology. That's the computing strand. These are the two areas that it leads into in stage 6, and Mr. Bailey was dealing with that. So we'll be focusing for this presentation on our first three courses across here: Design and Tech, Industrial Tech, and Engineering Studies. So hopefully we'll address some of the issues there. Due to the difficulty, obviously, with Zoom sometimes collecting all of the questions, we actually have a frequently asked questions document that we've created, and we will share it with you. So you'll be able to get access to that and also add to that. Okay. In addition to that, we've also got some links within the first, just underneath each of the courses that we offer here in TAS for the Stage 6 courses. That will direct you to the Board of Studies site, and you'll be able to find the intricate nitty-gritty details of what each course entails. So as opposed to perhaps getting too caught in the finer details this evening, what we really want to do is if you want to do a little bit more research, then you can actually dive in there and have a look. So those two documents will look a little bit like this. If we go to NESA, we can actually see that we've got a range of our courses. So Design and Technology Engineering, that'll give us a little bit about the course description, and that will take you to the syllabus. So if you need to know the intricate details about, for instance, what are the topics we study, the learnabouts, learn to, typical assessment schedules, etc., as deemed by NESA, value of major projects, and so forth, you'll be able to dive into here and have a little bit of a look at that. And that really is the case for all of your courses as well, so it's best to be prepared. The frequently asked questions, this is a document that's already started to take shape here, so you'll be able to take a look at the common questions that we seem to get each year to alleviate any of the sort of confusion, or just ask some really good questions, and you'll be able to add to that document when you get that link as well. So those are the two documents there that you can be made aware of. Okay, so what we'll be looking at is these three courses first. So we're going to begin with Design and Technology. So Design and Technology is really very similar to the course that ran in 7 and 8, which we would call Technology, the mandatory component. And your sons may, in fact, have studied that in Year 9 and Year 10. So it might be a direct link into those courses. However, it's worthwhile knowing that there's no prerequisites. So in fact, that may not have been the case. So there are no prerequisites. Obviously, the advantage is clear of having studied a course, but certainly you may have decided to pick that course up, and that's fine as well. So the main idea, obviously, with major design projects is how to manage the time, what sort of project selection criteria you can be considering, and a whole range of other issues that might crop up. Realising, of course, that you have another 5 subjects as well, so you don't want to dominate your whole academic profile through a major design project, so we try and manage those. So for Design and Technology, it's a design process. We're looking at solutions to authentic problems, and boys may make a product, a system, or environment, and you'll see examples of that throughout the presentation. Designing ultimately revolves around the notion of design thinking, so that involves a cyclic process typically, whereby you'll take a look at understanding the problem. So we're viewing this with a major projects mindset, and we're looking at identifying a genuine need. So in order to do that, we need to start by understanding what in fact that need is, what are some of the criteria, limitations, etc., and starting to really unpack the idea of the problem. Then what we move into the area where we start to say, right, now we're looking towards a solution. So once we've identified clearly what the problem is, then we start to work our way in, create some ideas, or this ideate and explore different types of solutions. That might involve drawing, sketching, prototyping, experimenting, etc., and doing some testing just to see if some of the processes, if some of the design ideas, prototypes, etc., are actually working well. Then, once we've made that, obviously then we want to evaluate to sort of see if that's going to work within the realms of the initial problem and if it in fact is a valid solution to that. So that whole cycle now is probably more commonly called design thinking, certainly in this new age, and that's the main focus of the course. So that'll provide us with good skill sets, not only for the course, but obviously for other areas as well. Often we are asked about the purpose of a lot of the courses and where they might lead and what sort of skills and how transferable those skills are. So here's an interesting article from the World Economic Forum, and they looked at this idea of top job skills for 2020, and you can see a number of those have actually changed the order from 2015 to 2020. But at the top of the list there, you've got complex problem solving, critical thinking, and the creativity, and certainly that's epitomised through the courses that you have. Jobs are often, and the fear obviously is that jobs are changing and the emergence of new jobs, and many of the jobs we talk about in the future probably don't currently exist now. So what are those skills that are going to provide you with the best, launch pad for transferring into this new sort of global economy with many of the job changes that are there? So certainly designing and a lot of the problem solving approaches that we study throughout there will provide some assistance there. So in order to be successful in the course, reasonable level of organisation is important. We need to document the process because essentially the process is key for design, and we assess the process as well as the project. But ultimately you could argue that there's no such thing as a perfect design, but certainly when we assess it, we assess the process, and there can be close to perfection in regards to process. So that is the key, and a good major project is usually epitomised by the beginning, which is an authentic and genuine need, and many of the projects you'll see here will range but will encompass many of those areas. And here's an example of Jono from a number of years ago, and his need was environmental awareness and how best to actually convey that message and make the wider community aware of it. Campaigns, he did some online things, and he also made some products, so he had a multi-pronged approach to it and was very, very successful with that. When they're authentic, they have universal appeal, and Jono ended up in the Northern Suburbs Times, and what he ended up there was getting some recognition in there as well, so that was actually quite pleasing there. So in design and technology, the areas that we actually look at are designing and producing, and also innovation and emerging technologies. So they're the two main areas. Designing and producing in Year 11 will involve minor design projects, and in Year 12 the designing and producing will actually involve the major design project, which is the main component for the Year 12 course, in conjunction with the theoretical component, which is along the lines with innovation and emerging technologies. So the breakdown is 40% for the exam and 60% for the major design project. Now that's for the HSC and the NESA mark. Obviously we then have an internal assessment process as well, but we're probably not going to discuss that in the presentation, but that's for the HSC. Ultimately that's what the students are called upon to produce. Matt Butler from a couple of years ago, there was an issue in and around a tragic accident at a surf lifesaving tournament competition. So Matt used that as a catalyst to identify a particular need, and then within that need he went about coming up with a solution, and it was very, very successful. Scored quite well at the HSC. He was nominated for the Powerhouse and actually won the Innovation Award at the Powerhouse. So certainly took it to the extreme there and did very, very well. In terms of where designing may lead, obviously that may not directly lead into industrial design, but many of our keen designers will actually run down that particular road. And just to give a bit of a case study of where are they now, that's Angus Bean from quite a number of years ago, who did very well in design and technology, then pursued industrial design as a course at UTS, and then he did a whole range of projects and a whole range of jobs within the design area, and he's won a national award because he's actually working on Drone Shield, which is a device that helps to rid the drone. So what it does is it actually sends an electronic pulse and disables the drones, and they just drop. So obviously a security issue in and around that. So that's a particular need. His company that have developed that need, and they've received some fairly wide universal recognition for that. So a little bit of an idea of where that can head. Some of the ideas for major projects, which are often the main key as far as the course is concerned, you have a wide range of projects. So Dan had a keen interest in the area of architecture, and he's studying a strand of that at university at the moment. So his project revolved around a surf lifesaving club, Long Reef, and redesigning the clubhouse. And he did that in conjunction with the actual club committee. He attended some meetings, he looked at earlier plans and produced a whole set of plans. So it's very, very much an authentic process. He spoke with many of the residents, he spoke with the club members and tried to come up with a design there. So very much an authentic process. Not only that, it actually benefited him into his future career options there. Where do we start in terms of projects? Major idea there is to think passion, think interest, think hobby, and this is a point we try and make. So there's a really wide range of projects you can see. Tim, keen mountain bike, and no surprises there. Ollie was a surf lifesaving, so he identified a need within his particular area there. So that stemmed from falling out of the rubber duckies and not always having the proper safety devices to cut the engines and the issues that might result in. So he designed a solution in and around that from a safety point of view. Liam, he was actually a very, very keen musician. So what he actually did was he did some coding and he came up with a music app that he found to be very, very beneficial. So he worked within his passion there. And Hugh, from quite a number of years ago, had a keen interest in jewellery making. So he actually came up with an Indigenous theme of jewellery. And to upskill, he actually attended some TAFE courses. So he actually did silversmithing and so on. But that was an absolute passion and a little bit of a lesson as well, because whilst others had fairly large, heavy major projects, Hugh used to carry his major projects around in his pocket, who's a smart one there. So that's design and technology. So that is the main focus with the D&T is the actual design process, and there's a focus on that. With industrial technology, it's similar to the wood and the metal the boys would have studied in Year 9 and Year 10, and that is a focus on the actual skills, materials and processes. So there's a clear distinction there. Both practical courses, both involving a major project, less of a focus on the design, more of a focus on the actual industrial processes for industrial tech. We have two focus areas, those being metal and engineering or timber products and furniture. So there's a classic example there of a project, not overly large, which is what we often like and encourage, but a whole lot of skills that have been shown in there, and that's ultimately what it's about, and they're the projects that score really well. So if you like making quality projects and you have a focus in a particular area, i.e. in the case of Angus here, he loved his metal. That's actually a log splitter, probably on the large size, but certainly that was a particular use to him. So fairly big hydraulic ram and system there, so he had access to a few of those resources, and he built that in the workshops here at school. There is a folio component, so often the students sort of think, oh, well, if it's industrial technology, no folio, that will be good, but the reality is that they need to produce a folio. The good news for both design and technology and industrial technology is there is a page limit. So the page limit is 80 A4 pages, which sounds a lot, but that's 12 months work, and often the good students are struggling to contain that and to keep that down to the 80 pages. So that just stops it from getting a little bit ridiculous in terms of the paperwork. So that was a great initiative into the course a couple of years ago. So DMC as well as a written exam. So the breakdown is the same for industrial tech as it is for design and technology. So it's 60% project, 40% exam. Here's some other typical projects that we've seen over the years. Once again, interests and passions. So quite a few guys are very keen on the surfing and making a handcrafted timber surfboard. It's obviously been glassed on the top, and usually each year we often get a couple of guitars, usually 1 or 2 guitars each year. So David from last year, very, very high quality craftsmanship shown there. And Walter from a few years ago now, he actually built a little wine cabinet there. So a mountain of skills, lots of inlays, some drawers, doors, and that's the type of project that really will score well. Larger project there. Henry probably been the exception, having a fairly large project in the presentation, but he had a definite need there, and I think he was bankrolled from a larger family, so they were fairly happy to pay the amounts there. And nice size project there from Alistair from last year. It was a traditional writing desk, but lots of inlays, lots of skills, and that would have scored very, very well, both in terms of machining skills as well as hand skills as well. So important for the guys to know that the markers are looking for a range of skills that are on show. Mitch, on the other hand, on the left-hand side with his grandfather clock, a very well-organised student from a few years ago. He actually had some wood turning there was some shaping, and there's a whole range of skills that he actually produced there, which was fantastic. Within the metal area, obviously that focus area, you do one or the other. You can't actually choose both. Within the metals area, there's a range of projects that have been made in the last couple of years. Really high quality one from Mackenzie last year, and that's for a Range Rover. So that's a sort of a bit of some tools for Range Rover. He's made up the sheet metal box, painted all that. There's some signage on the front. He also machined up many of the tools that fit neatly within the box. So that was a really clever idea. And Toby from last year, he made a toolbox that sat on the side of a ute, which was really good, and had some shocks there as well. So that's custom and built there. Obviously a fair need that he might have had, and workbenches are fairly popular and fairly common as well. Whilst for a number of years ago, both projects, they're worthwhile spending a moment on, because they're both exceptionally good projects. And if asked to judge, you would perhaps say, well, Nick Bait on the left, magnificent boat, probably the largest project that's been built at the school, did very, very well, band 6. And on the right-hand side, we've got a more modest project with a range of skills, some turning, a couple of drawers, some inlays, and a few other little skills incorporated. But Matt was... he was a fairly busy boy. He was involved in the cadets, first captain of the first cricket, captain of the first rugby. He had a busy schedule, yet he wanted to make a project for industrial technology. So he was mindful of his time, and he chose this particular project that he could achieve within the time. So they don't have to be big, and the markers certainly, as we joke with the boys, they don't weigh the projects. And I can tell you that both of those projects were band 6 projects. So that's something to be mindful of. It is not, I have to make the biggest project. It's more a case of making a sensible project. So that's industrial technology. Third course is engineering studies. Now, there's a Year 9 engineering, and there's also a Year 9 course on iSTEM, but the boys would not have in Year 10 studied any of these courses. So this would ultimately be fairly new. It ties in with the engineering at university, so it's a little bit of a bridging course, but once again, there are no prerequisites for that. It touches on many of the engineering principles. Being good at maths is handy. We do materials, so that ties in a little bit with the chemistry. We do mechanics, which ties in with physics. So the students will often find this as a great course that complements a number of others. So typically we'll have good engineering students, and they'll actually be studying advanced maths, for instance, or extension, and they'll also be studying chemistry and or physics as well. So they find the thinking goes quite well, and often D&T for that matter. So we look at the materials, the properties, and the manufacturing of a range of structures, and we also look at those through themed units, which you'll see. We look at the role of engineers, we look at historical aspects, and then we take a look at societal influence as well, and how they influence the design and the use of designs. So we study this through modules. So the modules are actually themed. So we don't do 4 weeks of drawing, 4 weeks of mechanics, etc., or mechanics on a Tuesday, or any of those sorts of structures. We teach it as an integrated unit, with the idea being that when we contextualize the learning within the particular field, that it actually will build some deeper understanding. So some of the old and some of the new, there's the pin joint there, Sydney Harbour Bridge, probably late 20s. In the prelim course, which is year 11, which runs terms 1 to 3, the 4 units that we do is a fundamentals course. So that gives us a little bit of an introduction and insight into the world of engineering. We look at an engineered product, so we look at some of the products and we do a little engineering report in and around some power tools for that unit there. We then take a look at a little bit more in-depth system there with braking systems. So we'll look at the historical influences and mechanics involved, some hydraulics, some drawing, etc. And then we'll look at biomedical engineering, which is fairly interesting and more of a newer area that a couple of the universities are starting to get a little bit more involved in, becoming a little bit more popular there. So we'll look at robotics and we'll look at different methods of manufacturing, etc. For the HSC course, which runs from term 4 year 11 into year 12 proper, we look at civil structures, we look at personal and public transport, aeronautical engineering, particularly enjoyable unit. We had a number of students who see that as a particular area. So it's a good insight into a whole range of different types of engineering. So they'll often see that as a good launch pad into aerospace engineering, that there's at least 2 students from last year who are actually studying that currently this year. And we finish off with telecommunications engineering. The course, primarily, we try and obviously teach it with a practical aspect, because engineering itself is of a practical nature. So some excursions to reinforce much of the learning that we take a look at. So steel production forms a major part of the course, and we head down to Port Kembla in year 11. In the civil structure units, not only do we go and see a couple of bridges. In Sydney, we're very blessed with the idea that we can get to see quite a number of the bridges that are in existence, both on the Harbour Bridge, and we also venture up the Parramatta River as well. But as part of that particular unit, the boys are asked to design, manufacture and test the destruction a bridge truss design. So they do that in balsa. There's some limitations, restrictions there, and it's a really, really enjoyable thing. The boys do like breaking things, but they actually get to break it, and hopefully it holds required weight, because that's actually part of the mark allocation as well. So very much hands-on where possible and practical where applicable. Career paths, once again, typically many of the students are looking at engineering as a career, and this gives them a good launch pad for that. Also might give them an insight into some of the work and some of the areas that you cover in order to get there. So students might find a particular interest in a particular area through the engineering course in stage 6. And here's Matt once again. He, as I said before, many of the students choose subjects that complement. So Matt, as well as being a pretty successful design and technology student and engineering, he also did high-level maths and he did physics as well. So he was always keen on engineering. He made that fairly clear, and he wanted to do some mining engineering, successful enough to get himself on the promotional video for Union New South Wales. And currently, I've kept in contact with Matt, and he's currently working up in Mount Isa in the mining sector there. So he's done very, very well for himself. So direct link from just that young boy there in the walking through the main breezeway in the main building on the senior campus there. So looking at the time ahead. So that hopefully encompasses many of the courses. Sorry, it's a little bit lacking in interaction, but apologies for that. There are questions, frequently asked questions that you can actually ask, and hopefully some of the answers are there. And feel free to have your boys look at that information, share that information, do a little bit of research, talk to maybe some mates in older years, and certainly if you have any questions, please ask. Thank you very much.